Hello students, today's topic is on random variables and probability distribution. So first we're going to have understand that what is that random variable means. Random variable is a numerical description of the outcome of an experiment. First point that is on your screen right now. Random variable is what? It's a numerical description because it means that every outcome of an experiment is reflecting certain numerical values, and that is the can say description of random variable, and it reflects the value of the random variable. Random variables are in two types. First one, or discrete random variable, is one for which the number of possible outcomes can be counted. It means that whatever the outcome will be there, it is possible for you to count it. Like when you are going to roll down the two dices, then two dices results, the addition of that two dices can be two, that is one on two dices, can be three, that is one or two or one, like this. It will be up to 12, right? Not more than 12 because two dices have maximum 12 values, in one 6, in another 6, right? Like this, it can be countable. Then continuous random variable has outcomes over one or more continuous intervals of real numbers. Continuous random variable is not exactly showing you the value that can be countable, but it reflects intervals of real number. We have certain examples also in another slide. This is examples in front of you on your screen of discrete and continuous random variables. Example of discrete random variables are outcomes of dice roll. Then outcomes of whether a customer likes or dislikes a product, that is also a countable example of discrete random variable. Number of hits on a website link today, that is also the random variable, discrete random variable. Then examples of continuous random variables like weekly change in DJIA. It's a kind of, we can say, example of an index that is showing in a stock exchange. So it is also showing you a kind of interval that between which index to between which index is going to variate. Daily temperature also the same, and the time between the machine's failure. So these are examples of continuous random variables. Then probability distribution. Now we have understood that what exactly the random variable means. Now the another important concept that we're going to have studied out right now, then is probability distribution. Probability distribution is a characterization of possible values that a random variable may assume along with the probability of assuming these values, right? So another important concept is about this probability distribution. A probability distribution is the characterization of the possible values that a random variable may assume along with the probability of assuming these values. So probability distribution is nothing, it's a kind of assignment of the values against the random variables in a distribution pattern, right? We may develop a probability distribution using any one of the three perspectives of probability: classical, relative frequency, and subjective. So probability distribution is basically a probability that assuming these values, that is random variable values, so every probability against the random variable values is considered as a probability distribution, right? So it's normally shown in the kind of graph or table that we're going to have discussed in our next slides also. So probability distribution is basically going to have three important perspectives. First one is classical, second one is relative frequency, and next one example of probability distribution of dice rolls.
that is a kind of Excel sheet on your screen where we have outcomes of the dices, that is 2. When we're going to have roll down 2 dices, then the sum of that 2 dices can be 2, that is 1 1, can be a 3, can be a 4, can be a 5, up to 12, right? Then in how many ways it can be possible, right? If it is 2, then it is only 1, because the 2 dices can, if you're going to have roll down the 2 dices, then only one possible chances is there where the sum will be 2, that is in both the dices the 1 1 will come. And if you're going to have roll down the 2 dices again, then possibility of getting 3 can be or 2 ways it will come, 1 2 or 2 1, right? Like this it will showing you here the number of ways, and then the probability we have counted, how it is, how we're going to have count that one. I will going to have show you on the Excel sheet also. Right now it's on your screen. We have two concepts in front of you on the screen. One is probability, empirical probability distribution. Another one is cumulative probability distribution. So as I told you, we have counting. We have calculated the probability by this formula 1 by 36. So the value is 0.0278. So the probability of getting 2 is 0.0278. So like this we have calculated the probabilities of all the values, and like this also we have calculated the cumulative probabilities also. We will go to have discussed later of what is the relativeness, or what is the usefulness of cumulative probabilities, right? So we have plotted a graph also, like this distribution graph came, and it reflects the distribution, probability distribution of rolls of 2 dices. Now empirical probability distribution, we can calculate the relative frequencies from a sample of empirical data to develop a probability distribution. Because this is based on sample data, we usually call it an empirical probability distribution. So from relative frequencies can be calculated from the sample of empirical data to develop a probability distribution. And we normally have take it from the sample data. An empirical distribution, probability distribution, is an approximation of the probability distribution of the associated random variables, whereas the probability distribution of a random variables such as one derived from counting arguments in a theoretical model of random variables. So empirical probability distribution is nothing, it's basically showing us a probability distribution with the associated random variables. So whatever the variables will be there, with that variables, whatever the probabilities are associated, when we're going to have plotted on the graph, then that distribution have reflecting on a particular layout, right? So this is called a empirical probability distribution. We have an example also in front of you. This example we already have discussed earlier also, where we took an example of computer repair time, and we have a total 42 to 43 samples are there, and we have calculated the frequency. Frequency is already there in our data. We have calculated the relative frequency. Frequency in the sense that in 5 days, how many computers have got repaired. So it is 1. Like this, we have certain data with us, and then we have calculated the relative frequency. So what is the probability here of repairing of one computer in 5 days? So like this, we have this is the empirical probability distribution. This is the probabilities values that is in relative frequency associated with the random variables, right? And here it's a cumulative. Okay, then Subjective probability distribution is nothing, is a probability distribution that using the expert's judgment, right? Or that is based on certain phenomena or any other decision models, right? Then subjective probability example is in front of you. If an expert have assessed that how a particular index of stock exchange is going to variate in a particular way, that what is the change will be there, that is an example in front of you. Again, it is formed under MS Excel software. Now the important concept that is on your screen right now, that is the discrete probability distribution. So in discrete probability distribution, for that first we have to know the discrete random variable, that is capital X. The probability distribution of the discrete outcomes is called a probability mass function. So the probability distribution, so whatever the distributions will be there of a discrete outcomes is called a probability mass function and is denoted by small f and small x. The symbol xi represents the ith value of the random variable capital X, and fxi is the probability. So this symbol, this xi is basically what it's representing the ith value of the random variable x. So whatever the random variable x is there, its xith value, xi is basically representing its ith value, right? Properties, the probability of each outcome must be between 0 and 1, the same as like probability, and the sum of all the probability must add to get the 1. So this is an important concept of discrete probability distribution. The major thing that we have to understand is here, what is the probability mass function. Then an example in front of you on your screen right now, probability mass functions for rolling 2 dice, right? So xi equal to the values of the random variable x, right, which represents sum of the rolls of 2 dice. So xi is basically what is the value of the random variable that is capital X, and it shows you the sum of the 2 dice that I already told you. Sum in the sense x1 is 2, that outcomes are there on your screen right now. x1 is 2, x2 is 3, right? Like x10 is like this, all the values are there. x10 is 11, x11 is 12, right? So these are 2, 3, 4. So these are sum of 2 dice. So when you have rolled down the 2 dice, then 1 1 is 2, then 1 2 2 1 is 3, then 4 is 2 2 will come, or whether it's 1 3 or 3 1, like this. The number of ways will be 3. So like this, the sums are on your screen. The number of ways also there, and the probabilities are also there that associated with that outcome. So the mass function of x1 is what? 1 by 36. That is the calculation of probability. Outcome divided by total outcome, right? Then it's 0.0278, that is on your screen. Then fx2 is 0.0556, like this it's calculated. So this is a probability mass function for rolling 2 dice. Now cumulative distribution function. So it's basically cumulative in the sense when you want to have an addition of the probabilities up to certain outcome, then it's called a cumulative probability distribution. Cumulative distribution function is representing as capital F and small x. Specify the probability that the random variable capital X is there, assumes a value less than or equal to a specified value, right? So whatever the specified values is there, we're going to have assumed that the probability up to that is of that value, and below that value is a particular value of the probability in a particular table. So I'm going to have show you that also, and that we're going to have clear more in the example. Then capital Fx, that is cumulative distribution function, is equal to probability of random variable capital X less than or equal to then that particular value of that particular series, right? That is on your screen right now. Now, for of rolling down the 6 will be this one, 0.01667. But if I'm going to ask you that what is the probability of rolling down 6 or less, then we need a cumulative distribution values, function values, right? So up to 6 means that this value we want, because up to 6 means addition of all the probabilities or individual probabilities, and it's cumulated up to 6, right? So that is the 0.5833. Now another question is there, the probability of rolling between 4 and 8. So for that, what we should have to require, the probability of 4 less than or equal to our random variable x, then less than or equal to 8. So random variable should be associated with this between these figures only, or it is equal to 3 or less than or equal to x, or less than or equal to 8. So it should be up to 3, or it should be equal to or less than 8. So I'm going to have show you. Then what they have did, they have get the probability between 4 and 8. How? The probability of random variable x should be equal to or less than 8 minus probability of x should be equal to or less than 3. So here the cumulative frequency up to 3, we have to get the value. So what is that? Its value is 0.0833. Right. Now next one is up to 8. Right. So if I'm going to up to 8 is how much? 0.0722. So when I'm going to have minus this with probability less than or equal to 3, then I got the area between 4 and 8, right? Because this much is left, so this much of area is left between 4 and 8. So I have got the value between 4 and 8, that is 0.6389, right? Like this, the cumulative distribution is help us to understand, right? Cumulative distribution function you can able to understand. Even we have one graph also where we have added the value and we have calculated put it into the graph also, like this. We have Excel sheet, right? Now this are the values.
These are the values, okay, for calculating our probability distribution, probability mass function, and this is the cumulative. Right. This one is cumulative and this one is probability mass function. So this one is calculated from this figure, where it's like increasing graph and it's like going up and down graph, right? So these are the two mass function and this is the probability mass function. Okay. Now we're going to have discuss the another important concept that is of
What is that? Expected value of discrete random variable. The expected value of random variable corresponds to the notion of the mean or average for a sample. So whenever we're going to have calculate particular mean or average of a sample of a particular probability distribution, discrete probability distribution graph or value, then it's considered as a expected value, right? For a discrete random variable, that is capital X, the expected value is denoted as EX, right? EX is the weighted average of all the possible outcomes where the weights are the probabilities. So EX is considered as the weighted average of all the possible outcomes. So when we're going to have roll down the dice, so whatever the possible outcomes are there, when we're going to have show it on a graph, then the concept of probability distribution arises, right? Why we need a probability distribution? Because it shows us a possible outcome of a particular event. So when we're going to have roll down a dice, the total 12 possible outcomes are there, and with that 12 possible outcomes, every outcome have one associated probability, and that is also we're going to have show in the form of probability distribution. So here the expected value is what? It's the weighted average of all the possible outcomes where the weights are the probabilities. Okay, so here we're going to have a particular formula also showing on your screen, that summation of xi means the ith value of random variable multiplied by its function. Its function means its probability, right? So when we're going to have multiply the ith value of random variable with its correspond probability, when you have multiply with both of it, then its expected value, the sum of all, the average of all this is considered as an expected value, right? For example, in front of you, the rolling down of two dices. What I have did here, I have multiplied the outcome with its probability, and when I am going to sum all this with each other, the value that came is considered the weighted average value of expected value of x random variable, right? Okay, here on your screen, that is outcomes values are there, then probability is there, and then its multiplication and the addition of all this came as expected value. I will show you in Excel also. I have calculated the same in the Excel also, that here we have outcome, we have probability value, right? Then we have multiplied it, and then we have got one particular 6.99. If I'm going to have, as I already told you, if you have to work under MS, then you should know the particular functions also. If I'm going to have format this cell, and I need a general in which number also, which I don't want. If I want only one decimal, the value will be 7. That was in your earlier in your particular example. Now, expected value is very helpful for the analyst and for the industry also to know certain values in the future, that what exactly it will be, how you're going to have help the industry, that I will show you. It's helpful for the games also. Through game, one of the game is there, that is deal or no deal is there. One of the game is very famous game. I don't think I don't know whether you people have know about that game or not, but if you're going to have search it on the internet, you're going to a lot of going to get a lot of videos about deal or no deal. In this game, what happened? 26 briefcases are there, and one briefcase is with the contestant only, and the remaining briefcases are in front of them, and they have to tell one figure. For example, 26 briefcases are there, so each and every briefcase have associated with certain value, that is from rupee 1 to 1 crore. So once they're going to have asked that briefcase number 26 I have to open, then whatever the value will be there in that particular briefcase, it will remove from the game. So like this, all the briefcases have removed from the game, and at the last, that briefcase was there present in a particular game. In front of them, that briefcase and their own briefcase. Then the banker has going to ask them whether you want that briefcase. So if the value, if I'm going to if the expected value is high, then I took the banker's offer. If it is, if I feel that the expected value is more, that banker is offer me, then I'm going to accept that briefcase. If I feel that no, in that briefcase the expected value, whatever it is, there is less and briefcase value is more, then I'm going to accept that briefcase. So like this, the calculations are there for this particular example. That is on your screen. Certain points are there. At the last of the game, 5 briefcases are left. Right, in that 5 briefcases, 100, 400, 1000, 50,000, and then 300,000 dollars are there. So in this, the contestant have not an idea that in which of the briefcase what amount is there. 5 briefcases are there. One briefcase is of $100, then another briefcase is of $400, then $1,000, $50,000, and then $300. So 300,000 we call it, right? So it's a game. So under this game, the last 5 briefcases have left, that is of $100, $400, $1,000, $50,000, or $300,000. So a contestant have not an idea about in which of the suitcase what the value will be associated. So expected value of briefcases here is what? 70,300, right? And then we'll get, I will going to have calculated on the Excel sheet about these values. That is on the screen right now. Point 2 is our probability, 1 by 5, then multiply by 100. Like this, all values came, and when we're going to have added, then total value is 70,300. So expected value of all these outcomes is what? 70,300. So banker has offered him $80,000 quit, which is higher than the expected value. So instead of that, the probability of choosing $300,000 was only 0.2, right? And so the decision should have been easy to make. So if we're going to have choose the $300,000, so the chances is getting more less. How? I will show you on the screen again. Now see here, if the contestant has choose the $300,000 box, then what happens? That box is removed from the game. So how many boxes then left? 4 boxes are left, right? And in this case, the probability will be 1 by 4. And then when we're going to have added and get the actual amount, then it's 12,875 points. Right. So that like this way, the expected value is going to be very helpful for the analyzers and analysts. Another example that is important for us to understand is the expected value is helpful for making the decisions also, like in air drive revenue management. I think most of you have understood this concept. Whenever you're going to have book a ticket 20-30 days before, or 1 month, 2 months, 3 months before, then the values of that airline tickets are different. And when you're going to have choose it just before 2 or 3 days of your expected traveling itinerary, then the charges are quite high. How these airline industries have adjusted these values are more understandable through this example. Full, and for example, we have only two fares. One is full, another one is discount airfare available for the flight. Full fare ticket cost $560 and discount ticket cost is $400. Our random variable is what ticket price paid. So whatever the ticket price paid, we consider as our value or random variable. Then probability we have 0.75, the probability of selling a full fare ticket. We already have a probability value. So the expected is what? The expected value is 0.75, that is probability, multiplied by our full ticket fare, the probability of getting 560, of getting fare of 560. We already have a probability of full fare ticket. So probability multiplied by that associated random variable only. So 560 multiplied by 0.75 plus 0.25. Because what happened? We already have studied the complement concept of probability, a complement, where the probability, when you to have minus by 1, the remaining probability is a complement of that probability. So when you want to have multiply minus, then 0.25 remains. 0.5 is a 0. Why we consider he's a 0? Because here the discounted, we are not considering the discounted fare. For total fare, we are getting the 420. So expected value is how much? Is 420, and that is what? That is more than the discounted ticket cost. So if it is more than the discounted ticket cost, so we should not have to discount the full fare ticket, because the expected value of a full fare ticket is greater than the cost of discount ticket. So like this, we can have the calculations, right? And here also that they have calculated the break-even. Okay, at break-even probability is 0.714. $400 equal to probability of $560. Then probability value will be 0.714, right? So like this, we can have a helpful, we can have certain calculations that are very helpful for us in the real life situations also, right? So here the airline should not discount the full fare tickets, because the expected value of a full fare ticket is greater than the cost of discount ticket. So as we have find here, how we're going to have calculated the expected value, that is probability multiplied by the particular outcome and plus the summation of another probability multiplied by a particular outcome. So one outcome is either fare, full fare, or have no fare. So when we have calculated this thing, we got the expected value, and expected value has more than the discounted cost, that is $400. So here there is no need to have discount the full fare ticket, but what exactly the break even will be? Break even will be what? The discounted fare, it is going to have equal to when the expected value is equal to $400. Then what could be the probability? So the $400 equal to expected value is what? Probability multiplied by our outcome, that is $560. then we'll get the probability of 0.714. So that is a quite good probability. If the break even, if the value reduce it, the particular full expected value, then it is better to reduce the fare. It is okay. So like this, we have a calculation and that to understand it. Then certain more examples are there. After that, we're going to have start our new concept is Bernoulli's distribution, right? So in the next class, we will have discussed this one. So for today, it is sufficient, and we're going to have discussed in our next class.